the Yichen, right? Okay, so if you look forward, right, you realize something, right? You realize that you're a bit different from everybody else, right? Correct. And the reason is because you weren't here on Friday, obviously. The rules of this class is that you occupy the first 6 rows. Thank you very much. Yichen. Yeah. How does this work? Okay. So today's class is a bit special. Today's class, your friendly neighborhood tutor, Jinwei, is now giving out your dog gift. So today you get dog gifts. How cool is that? Alright, so while I get this thing in order. Okay, first of all, if you're not really familiar, this is IVLE, okay? And I don't know how many of you have seen the announcement that I just made. You have already been given the URL to log into the Jedi Academy, so you can do that at some point. But in addition to the Jedi Academy, you will also be using IVLE quite extensively. And this is IVLE. Alright. IVLE. Yeah. So what happens here is that you come here. Okay. What? Just receive well, very slow. I put it in the system half an hour ago, so you know there's a lag. Okay. So so one thing, okay, listen what you want to do is, okay, generally speaking, you want to look at this thing called lesson plan. Hello, see here? Okay, so the lesson plan will basically tell you pretty much what happened this whole entire semester, what is going to be issued, what's going to be due when, okay. It will give you the lessons, okay, even Saturday lessons are here. Okay, so you have the readings, or the appropriate readings, plus the lectures, the lecture slides, webcasts. Okay, so it turns out that webcast for Friday is already online. I hope it works well. I haven't seen it myself, but it's here. Okay, so this is where you should actually look at what's happening in the class. Okay, so the whole entire schedule for the entire semester is all here. Okay, and okay, so today is the first proper lecture. Friday's lecture obviously is not a real lecture. Today basically also is a rather slowish lecture. So the pace of the class will start to pick up, okay, over time. And today is a kind of warm up, you know. Before you start sprinting, you need to warm up, get muscles in order, and then you go. Okay. Yeah. And just to highlight to you, so unlike other modules in this school, the recitations will start next week. Okay. Currently, recitations are scheduled every hour from Wednesday 1 o'clock, Wednesday 2 o'clock, Wednesday 3 o'clock. Okay. So next week, because none of the other classes have tutorials yet, so you should be free. You just turn up for whichever session that you feel like it, and then if too many people, then you come for the next session, whatever. Okay, you should be fine, alright, for next week. And then subsequent weeks, we will probably have to reschedule the recitations, okay, to times where you guys can make it. This year, because of U-Town, there are a lot of scheduling changes. So next week is going to be a mess, but we'll deal. Other than that, location is, okay, good question, location. IVLE is very useful. IVLE goes to here. Okay, timetable. You will see all the different recitations, the tutorials. Current location is now Com 1207. I'm not sure which room that is, but it's so here you can see all the recitations and all the discussion groups, right? Okay, sorry, one moment. Let's do this one. Open. All right, so we're about to start. Okay, can I just quickly check? All of you registered for the class? I mean, are you all seeing? Okay, I know Li Xuanji has a problem. Mr. Sir, first 6 rows, thank you very much. Li Xuanji, okay, the AUS High students are for you. So Li Xuanji has a problem. He's still not in IBLE. Anybody else has a problem? All you are already registered, right? You all can see the class in IBLE, correct? Can? Anybody here is supposed to be in the class but cannot register? I mean, haven't seen the registration. Oh, okay, very good. All right, so we'll start. All right, so first of all, I would like you all to take this. Somebody asked yesterday whether you should do the survey. Please do. Okay, so this is what you call a background diagnostic test. Truthfully, it makes no difference here to you. This thing is not tested. It's not for anything. What we are trying to do, okay, you guys, those who do you do this test will be guinea pig. We are trying to develop kind of a background diagnostic test to check whether or not Naomi, right? Only a 5, 6 rows. Thank you very much. What we're trying to do is to make sure that we create some kind of test to have some background diagnostics, okay, for the students. And you are just guinea pigs. I mean, we're trying to develop this test, okay? So just do this, and there's a reward for this, okay? You will get experience points. So the cool thing about our test is that, I mean, about this class is that we give experience points for everything that you do kind of right. Okay, so if you, okay, and this must be done by Sunday. It's tomorrow, that's very fast. Okay, I give you till Wednesday, okay? It's quite simple. You should take you more than 15 minutes to do, okay? Just do it, and then if you finish before Wednesday, you get 100 points. You don't do before Wednesday, you don't get 100 points. Okay? Yeah, correct. It's all or nothing. You know, and it's not about how well you score, right? The whole point here is just do it honestly and just do it. It has no bearing whatsoever on your grades for the class. What happens at the end of the class is that we look at your score, we look at your final grades, we do some correlation kind of thing to see whether we can do come up with some kind of assessment thing that can predict how well you do, whether or not who are the weaker students, so you can give more attention, that kind of thing. So this one is not a real teaching tool. This is actually an experiment. Okay. So if you help us in an experiment, you get rewarded by 100 XP. Okay. And finish this by Wednesday. Okay. Your score has no bearing. Just doing it is enough. Okay. Doing well is not necessary. Okay. So the first thing to understand, before we continue, let me just say that if I do speak too fast, what do? You put up your hand and ask me to repeat. Or if there's something that I say that is not very clear, you put up your hand, ask me to explain. Okay. Today's lesson is relatively simple, so most people should be okay. Okay. But as we progress, it gets more complicated. Okay. And another thing I do is that I will put up the slides, okay, before the lecture. Okay. Those of you who think that the class pace is a bit fast, you may wish to read the slides before, so you have a sense of it before we come to that class. Those of you who think it's very slow, you can just come and read just look at it, just watch me do my song and dance and enough. So you basically learn the material, right, at a pace that is comfortable for you. Okay. So the first thing to know is that 111s is not a programming per se. The whole point of this class is really learning how to think. All right. And the idea is this thing called computational thinking. Okay, so the whole point here is to learn how to think about problems, okay, using the methods that we teach you, okay, and to solve problems, okay. All right, and this is the roadmap. So by the end, okay, right now, I'm not going to waste time explaining to you all the different pieces here because frankly you have no clue, and I have no way of explaining this to you. But the general idea is to just get a sense that you are supposed to learn some stuff here, right? And obviously, in 13 weeks from now, I will show the same slide, and then y'all will go like, wow, okay, I know all this stuff. If 13 weeks from now you realize that, Sam, I don't know this stuff, then you're in trouble. Okay, so we'll be covering all these things, okay, and in your 13 weeks, you should all look completely obvious to you, Okay, all clear what it's about. Right now, it all looks kind of cool. Colors are nice. It's green, it's yellow and red, whatever. But just know that this is the general roadmap. Okay, and the way we do this is that we will start with the simple concepts and build up to the advanced one. Okay. Now, okay, it is possible. It is possible. And we have one business lady. What's a business lady? What's a business lady? Business lady, right? What's the name? Sorry. How do you pronounce the name? Hang, right? Hang. Okay, very good. We have one business lady. You all don't know, right? I know. Okay. So Hang is a business. Okay. It is possible that after this class, she's going to go to not Wall Street. I said not Wall Street, but maybe she go to Wall Street. But she has to go to the bank. She'll make tons of money. She has no need to do this programming ever in her life ever again. And maybe once now you may work for her. Right? She'll be your boss. Okay. So the point now is that after that, in a few years, there's no need for this. And then it's quite embarrassing. If people ask you, what do you learn in one S, then you don't know what to say. So let me just help you out. Okay. You tell them, I learned to manage complexity. Wow, this sounds very smart. Okay. So the key thing about this class is really about learning techniques to manage complexity. Okay. That's the key I take away. So today I'm going to go through all stuff, but if you remember nothing at all, and after you graduate, you make a lot of money, you remember nothing at all, just remember these two things, okay? Managing complexity. Okay, first of all, why would you bother to program, right? Okay. You could obviously one day become rich and a boss and then get people to do for you. But the main reason why we need to learn a program is because at this point, we haven't reached the Star Trek stage yet whereby you go, computer, do this, and then it does for you, right? Okay, so now, unfortunately, computers are smart. Sometimes they can even play Jeopardy better than humans. But there are limitations to what they can do. Okay, so they aren't that smart. And at this point in time, they will follow your orders completely, precisely, which is kind of cool and kind of scary. Okay, so the reason why is you need to understand how to program is, and because these computers don't really do very smart things, they just follow your orders, and you better know what to say to them. Okay. And of course, another thing is that computers are cool because they can let you do cool stuff. We will do quite a lot of cool stuff, hopefully, during this semester. Okay, all of you have got your dog gift, right? Hang, you got your dog gift? No, right? Okay, anyway, later there's a break. There's a break. And during the break, you can go and see your handsome tutor over there, and he'll give you a dog gift. Okay, show me the dog gift. Show me. So this is the dog gift. The dog gift is this really cool set of 3D glasses. You will know soon enough why you have 3D glasses. Okay? But this is the dog gift. So later, those of you who haven't got the dog gift, you come a bit late, get from your tutor. Thank you very much. And the tutor, give me the spares. The return the spares later. Okay. Okay, so the whole point here is this. In programming, you are communicating a computational process to the computer to help you. Hey, don't worry now. Now it's not 3D yet. I'm still only like that. Okay, so it's not for now. Okay, it's for you to bring home and you use it later. Okay, so a program basically allows you to to communicate a computation process to a PC. Okay, and why do we use scheme? Because they're simple, fundamentally. Okay, you all will be doing very advanced things by the end of 2 weeks compared to 1010, because 1010 we're still figuring out how to write syntax. Okay, so it allows me to accelerate the teaching quite drastically. Okay, you'll be doing quite some things before your fellow students in 111 I will do anything else. Okay, so the another principle here is that it's futile to teach a language. When I was in school, this is like almost 20 years ago, there wasn't Java really. This didn't exist. Java came out in 1995, which is when I was my third year junior. Okay. Anyway, end of my sophomore year, I was doing Java. One of the first few programmers in the world do Java. So this is like 20 years ago, 1995, 16 years ago, around there. Right. So since then, the pace at which languages have been developed has accelerated. Okay. So there are more and more languages at a faster and faster pace. Okay. So what happens here is really there's this concept of here today, gone tomorrow. It turns out that C is still quite it's still quite has quite a lot of longevity, it's still around. But many languages come and go. Okay, scheme will not be here, may not be heard that long, but teaching is kind of cool. Alright, so the point is not so much to teach a language, but to teach you how to think, right? Now, so first of all, this is all very basic elementary stuff. Many of you have background, so you bear with me. Some of you who has no background in programming, okay, slightly less than half. That's fine, fine. Okay, most years is about 50%. Last year was a bit more, less than 50%. But most years, 50% of people with no background. But it's okay. The people with no background actually can catch up and do better. It's actually okay. It's quite fair, okay? Because who here knows scheme already? Just checking. Only one. That's not the concept. That's only a workshop. You don't know that much. Don't worry. You know scheme already. Okay lah. So read textbook. I'm not sure you have to read textbook also. So actually the thing is very fair, right? Because even those with background programming, nobody really knows scheme. Okay. So even the guys with no background, you can come catch up because they don't really know. And actually you realize that those people who know how to program have a problem sometimes. Okay, because they know something else. Then I have a student 2 years ago. His code, if you look at it, it's obviously C code pretending to be scheme. I look at it, I know this is C code, but it's all parentheses, but you look at it, it's obviously C code, right? So how do I know that? I have to explain because I can program many languages, and I've done many things myself. So I look at it, this is C code, right? So sometimes knowing stuff may not be good because it actually makes it harder to learn. Okay, scheme is certain style. Okay, scheme is certain style programming. C is certain style, Java is certain style, and the key thing about being a good programmer is that you must be versatile in being able to switch, okay, your mind from one style to another style. So in that light, because scheme is kind of obscure, it's quite the guys with no programming background is kind of a more even playing field. So and you'll be fine, okay. So first of all, let's talk about elements of programming. Some simple things. First of all, they're primitives, right? What are primitives? Okay, so first, basic primitives will be numbers, okay? You have 4. 702 is what? It's a rational number, a fraction, okay, 3.5. And then you can have, there are floats, floating point numbers, 4.428.3, whatever. You have operators, simple, you learned this in kindergarten, right? Primary school, I don't know. Plus, minus, divide, okay? And you can have symbols, right? So these are the primitives. Symbols means that they're just names, okay? So you can name things, something, right? These are primitives. Okay, then you need to have, the next thing in the language is that you need to have this means of combination. You must figure out how to put stuff together, alright? Simple things are the building blocks. Combinations allow you to put two things together. And I think you have seen some of this already. The way that scheme does it is use parentheses, right? So we have left parentheses, right parentheses, in between is stuff, okay? And in this case, you have a plus, okay? So you are adding 5 and 3 together, so the answer is obviously 8, okay? So this one, what's the answer? Who says 2? Who says not 2? Okay, very good. All passing together. Very good, Okay, so the thing about scheme obviously is that it uses this thing called prefix notation, which means that the operator, okay, is put in front, everything else is put behind, okay? And it's quite logical, you look at it, you just do the stuff, inside stuff first, and then you kind of expand outwards, and it's done, right? So it's quite clear. Okay, next you need to have this thing called the means of abstraction. Okay, you need and actually abstraction is what we were talking about the whole semester. Okay, different types of abstraction. Abstraction is like data hiding. Okay, so for example, okay, one simple example is naming. Okay, so what's the answer? 11. Who said 11? Hey, you passed kindergarten, right? Can, right? Okay, so. Okay, so very good, not 11. So suppose then I say define A3, okay, and then I do plus A6. What's the answer? 11. Okay, so 9, right? Why? Because what I'm saying here is this, right? I'm telling you that I'm naming A is an object. So, okay, what kind of thing was name? I'm calling 3A, right? I mean the number 3, I'm calling A. And now when I add A and 6, I'm just saying that, A is not actually 3, so you add it together, you get 9, right? Okay, this is a way of abstracting. Okay, now there are many more abstractions that we will talk about later, but these are key ideas. Okay, so scheme is expressive. Okay, so suppose you see this thing. Define square x star xx. Okay, what is it telling you? Okay, it's actually saying something like this. To square something, you multiply something by itself. Simple, right? Okay. So this is square x. So suppose I do square 2, what happens? Okay, very good. He also passed kindergarten 4. Square 3? 9. Oops, too fast. Okay. So square 3 does what? You square 3, you get 9. And then you square it again, you get 81. Okay, very simple. Okay, so from this example, it should be quite clear that there's a way of evaluating this scheme expression, right? And the way you do it is quite simple. So in this case, what happens? Okay, obviously you can write out an answer, but let me just quickly go through this. Okay. Oops, what happens to this? Okay, yeah. So what happens here is that you first do the inside parenthesis. 3 plus 4, you get 7, right? And then you do the other parenthesis, you get this thing. And then you do this two together to do this. So the general idea here is you first evaluate what we call the sub-expressions. Okay, sub-expressions are the smaller things that's inside the parenthesis. And then you slowly kind of, finish them one at a time, and you do the bigger one. Okay? It's quite obvious, right? Okay, so things are quite obvious, it's okay. You go through this systematically, and then after that you apply the operator. The operator is the thing that's at the beginning, the first thing. Okay, so it's a prefix notation. So the first piece in the parenthesis is the operator, and then you apply the operator on the sub-expressions. Okay? Okay, very good. So this is how it works. Okay, now there's this thing called environment. And this concept is common for pretty much all languages. There's something that keeps track of what's happening in the system. Okay, so scheme keeps an environment, which is actually a table somewhere. Okay, and this table remembers things. Okay, in particular, it remembers associations between symbols and values. Okay, so what happens is that when you do a define, okay, the define statement would add what is really a kind of a mapping. Okay, this table. Okay, for example, if you do define x3, what happens in the environment is that you add the entry x3 inside there. Okay, and obviously you can do the same thing. Y5, this is how it happens. Now it turns out that then when you do multiply x, y, what's really happening is this. The star is actually a predefined value in the table itself. This the scheme, when you turn on Dr. Scheme, right? It has some stuff already predefined, and it turns out that this star is actually already mapped to a multiplication operation that is kind of an object. Okay, and essentially what happens here is that you will actually look up this object and apply this object on this 3 and 5. So when you run this thing, you will do eval. You will actually look up the values of this, and this. So the value of star is this object. The value of x would be this value here, and y with this value, and then it actually operates multiply on 3 and 5. Okay. Obviously 15, you know this. Okay, so the next thing to understand is this. Okay, so in scheme, we also have this thing called procedures. Okay, and in fact, almost every language there has this kind of ideas. In scheme, they're called procedures. In C, they are called what? Functions. In Java, they are called methods, right? Okay, it's all the same thing, right? So the point now is that essentially you associate a name to a sequence of operations, right? So in this case, square, you are associating the square name square to operation whereby you multiply something by itself. Okay, so this is what procedure is, and this is how you define a procedure. Okay, so the general form of procedure is the following. Okay, so there's some syntax. Okay, C and Java has a lot of syntax. Scheme has a lot less. But nevertheless, there is still some syntax, and we have to learn some of the syntax. Okay, so define has the following syntax. You define the name of the procedure. Okay, then there's this form parameters. You all have the same functions, right? F of x, right? F of y, g of x, y. Okay, so f of x, the x is the formal parameter. Okay, but you know the functions, you can have multiple parameters, right? You can have g of x, y, right? So is that like you can have a name of the function, you have some number of parameters, and then the body is essentially the instructions on what to do. Okay, simple. Good question. What happens if you try to be funny and have two try to put in two parameters with the same name. Why don't you just try it out and see how, right? I mean, okay, so some of these questions, I leave you to try out. Excellent, this is very good. I like this kind of curiosity, okay? So you should always asking this kind of questions. This question I don't want to answer because you can figure out for yourself. You just go to Dr. Scheme, type it out and see what happens. Okay? But quickly, what do you think will happen actually? Okay, one possibility is one override the other, yes. This man wants to give us, what's the name, sir? Basically it freaks out and dies. Okay, so if you try to be smart and do something weird here, either something bad happens or the interpreter will freak out and die. In this case, he freaks out. Correct? What's the name, master? Woon Hian. Okay, so along the way, I will try to learn your names. Your name, sir? Jan. Jan what? Jan. How do you spell that? Jan and Woon Hian. Okay, very good. Okay. Okay, so answer. This is more start primary school already. 441. Very good, This one? Okay. This one? Okay, very good, Simple? Okay, so this is all very simple. Okay, now then the thing is this, you can do the following, right? You can say that the sum of squares is what? The sum of squares x, y, you can then say is the sum of square x and square y, right? So when you do sum of square 3, 4, you get. Okay, very good. The math is quite good. Okay, next I can define this. I can define hypotenuse AB to be what? The square root of the sum of squares AD, right? So hypotenuse of 512 is 16. Who said 16? 13. This is your famous triangle, right? Okay, so okay. It turns out just now what I told you is the following. It turns out, okay, this is now this is where it gets a little dicey, and people get kind of confused. It turns out that what we said just now, the defined name form procedure body, is equivalent to defined name lambda form parameters body. Okay. This is where it gets a little dicey. Okay, so anyway, this is true. Okay, and we call it syntactic sugar, which means what? It turns out that the form that we actually run is the second form, which is the following. Okay, what it's saying is this. It turns out that lambda is actually the special form that creates this procedure object. Okay, what define does? Remember what define does? Define what? Define actually creates a mapping in the environment table, right? Between a symbol, which is the name, and an object. Okay, so what really happens here is that lambda over here creates the procedure object. And what define does is that it maps this name to the object. But if you look at the bottom, it's kind of nasty, having to type so much stuff all the time. So typically we write this thing upstairs because it's much more convenient to actually type. Okay. Now let's take a look at it. So the idea here is that lambda is actually it actually means to make anonymous procedure. Okay. So for example, if you type in define square x star xx, what you are really doing under the hood is that you're defining square to be lambda x star xx. Okay. And like I say again, the interpreter will see you type in the left side, the interpreter will look at the left side and automatically kind of like interpret it as the right side. Okay. Okay, this may not make sense yet, but after a while you figure this out. Okay. So just for now, you just understand that this is true. Okay. The sum of squares, same thing. Define sum of squares xy is the same as defining sum of squares lambda xy then plus whatever. Okay. And this is a weird one. Okay. So suppose you do this weird thing, which is define open parenthesis 1 1. It's actually the following. It's actually define 1 lambda nothing inside 1. So procedures do not always have parameters. It is possible to have a procedure that doesn't take any parameters at all. Okay? Are we clear? Any questions? Okay, just stare at it for a while. This thing takes a while to sink in. Okay, so it turns out that define is a special form. Alright. We'll talk about special forms, I think, in presentation or I forget when. I'm a little bit old now. But we'll talk about special forms very soon. But anyway, just to understand that define special form the special form essentially is something that doesn't evaluate the normal way. Okay, so in this case, the special form defined does the following. It actually evaluates the expression, which is the right side. Okay, you get some value out of the expression. Okay, and then it actually adds to the environment table a mapping from the symbol, which is the second thing, to the value of the evaluated expression. So, okay, so what's special form? Huh? Now, the way that, okay, this is interesting because what I'm going to say sounds damn obvious, and it is quite obvious, okay? But you have to understand it very clearly in order not to mess up, okay? Now, it turns out that to evaluate scheme expressions, there is a certain way of doing it, okay? And it's this thing called eval applied, okay? And this one we'll cover it very, very thoroughly during the presentation, so there's no confusion. But for now, we just have to go through this relatively quickly. So, what happens in the evaluation of this scheme expressions is that, okay, the parentheses stuff, this is known as a combination, okay? So, to evaluate a combination, what you do is that you first evaluate the sub-expressions, which I told you before, and then you apply the procedure, which is the leftmost stuff, on the sub-expression, okay? To apply a compound procedure, what happens is that you evaluate the body, okay, with each formal parameter replaced by the corresponding value. Okay, this one sounds very obscure. It's easier to see it in practice. Okay, but so I'll show you later. Okay, so the reason why you need this RSM is because, okay, it turns out that most times, okay, you can what you call eyeball the answer. Okay, oftentimes you can eyeball it. In recitation, I will show some nasty stuff which you eyeball too hard, eye will pop up. Okay. So you actually need to make sure that you understand these rules, because if you don't understand these rules properly, you will not be able to evaluate the expression. Okay, so this is for nasty cases, and in exam I may give you a nasty case because I won't give you some simple thing where you can eyeball. Okay, so this example I said you'll see in recitation. I will show you some examples for which it's not so easy to figure out what's going on. Okay, back to the same key idea. So the idea that we're trying to deal with here is measuring complexity. Okay. And okay, in case you haven't, you all received the SMS, right? Okay, and what you get is this thing. Okay, so this is the URL. Okay, is quite interesting. Okay, who here is not on Facebook? Nobody, right? Oh, you're on Facebook. Very good. No, Richard is not on Facebook. Oh, is it? Oh, okay. So, okay. Anyway, Facebook is the in thing lah. So most people are on Facebook. It's not a shame. It's okay. There's Google Plus. Okay, those of you who want accounts, I can try to give it to you. It seems to work actually. But nevertheless, the thing is that you need to be on Facebook because this whole thing is actually Facebook integrated, Facebook connected. Okay. And then when you level up, the whole world will know. How cool is that? All right. So this is, you can try this from today. Hopefully, there are no more bugs. Okay. Alright, so any bugs, essentially two things. You can either spam this email address where the tutors are all squatting there to fix, or you can post an IBLE, okay, whatever, somebody will take care of the bugs. Okay, so late policy. Okay, so, okay, this is not much of a problem. Okay, in the past, it used to be a problem. In the past, people used to submit things late. For the first half of the semester, I don't foresee any problems. First half semester, people will submit early, so I don't really see any problems. Towards the end of the semester, when things get kind of dicey and then people get kind of busy, things may happen. The policy is very simple. If you are 10 minutes late, okay, already the assignments are due 2359. You know right? Who knows what is 2359? Who doesn't know what is 2359? Okay, very good. So you don't know what 2359 is. Okay, the NS boys will tell you, the guys who do NS will tell you, 2359 is a clock kind of, it tells you it's 23 is 11 p.m., 59 is 59 minutes. Okay, so 2359 means it's the minute before midnight. Okay, is it like Cinderella? Okay, so basically all the assignments are due 2359 or whatever day. Okay, but then every year the students will complain, I can't get on time because your server is slow, right? Right, correct. It's our fault, right? It's always our fault. Right? So because our server can be slow, because people would like to coordinate and submit at the same time, right? So we give them 10 minutes of grace. Okay. So if you try submitting, okay, even if you submit, Even if you start submitting your assignment at 2359, in 10 minutes, you're only 40 of you. Okay, 10 minutes is sufficient to submit all the assignments. Okay, so the 10 minutes grace is more than sufficient to take care of any server slowness. All right, this is the logic. Makes sense, Okay, it's very wise, right? The prof, because we've done this many times. Okay. Now, then there are some people who will still be slower. If you are half an hour late, we will knock off 10% of the points. Okay. And some people will somehow cannot finish on time. 12 hours late, you have 20% off. Okay. Like then one day late, better still. Great Singapore sale, 50%. Okay. After that, no more already. So it will give you up to 24 hours grace. Later on, that's very cool. Later on, I think along the way, we'll give you this bonus batch, right? Which is something like, you can use it's an achievement. You can translate it into one extra day, one day, grace or something, forgiveness. It's kind of cool, okay? But for now, given what you have, the first 2 assignments are quite easy. You shouldn't need to have any problems, okay? You get used to this. So this is the late policy, okay? And submission is final. So essentially, you type your answer, right? That you need to press submit. Okay, because we don't know. See, the point now is that you can save your answer. You can work halfway, save your answer. That may not be final answer, so we don't really know. Okay, so when you're really ready to submit, you press submit. Okay, and then the solution is frozen, right? Obviously. Now, obviously, I can say this. Okay, it's supposed to be final. Now, some of you guys will press submit. No, you see, you press submit. You ask you, are you sure you want to submit? And you go yes, no. And then 2 seconds after, you realize, damn, I didn't really want to submit, right? Okay, no. This is going to happen to you. I guarantee you. So you must know who your TA is. And then what you do then is you panic and you send email. Oh no, I didn't want to submit. Can you help me? Okay. And then one of your kind TAs or maybe me, okay, will unsubmit for you and of course scold you, okay. So some of you will screw it up a few times. But I expect you all to basically, after a while, get some sense in your heads and not do the wrong thing, because it's a pain, Okay, and now, if you submit wrongly and 2 seconds you realize send email is okay, If you submit wrongly and the assignment is graded, sorry, no refund. Clear. Okay. So it may be okay, if you have Joe Chi as a tutor who is squatting there, camping there, waiting to grade your thing, then maybe it's not so good, Okay, so then but if you're someone who's a bit more slack one, then maybe you have more time to unsubmit. Okay? But I say again, if you submit wrongly and you want to undo it, you quickly email your tutor or send the staff list and say, sorry, I screwed up. Okay? If you fail to do that and your assignment gets graded, then the answer is the result is final. Okay? It's graded as soon as you submit. The tutors are competing to see how fast they can do. There's a leaderboard also. Sorry, you don't see it, but I see it. It's very fun. There's actually a leaderboard among the tutors. Okay, which ranks them according to how fast this class is a little bit warped, okay, but they have this leaderboard among the tutors to compete how fast they grade their tutors, the students. Okay? So yes, they will be grading. So 24 hours is max, okay? Basically, when you submit, they get this email that says that you better grade this in 24 hours or the prof will eat you. Okay, so if you don't get eaten by the prof, they will grade within 24 hours. So 24 hours is like the upper limit. Okay, last year, Caleb Chow managed to bring it down to, he has graded stuff like within 10 minutes of submission before. So it is possible that you submit, in 10 minutes you get the answer back. It is perfectly possible. It all depends on how sell on and whether your tutor is camping waiting for you. Questions? Yes. No. We don't really want to have bonus not for that. Yeah. Okay. All right. So back to this thing. Okay. So procedure, as I mentioned before, is a operation that associates the name with sequence of operations. Okay. So the general idea here is this thing called procedural abstraction. Okay. So essentially, we're hiding some details. So what does it mean is this? So essentially, with procedural abstraction, you are looking at a procedure as a sort of a black box. So you put in stuff, and out comes some stuff. And the key principle in procedural abstraction is that you just need to know what the box does, okay? And you don't need to know exactly how the box does it, okay? This is kind of the cool part. Okay, it's a very simple idea. In fact, many of these ideas that we'll be exploring with you are very simple ideas, okay? Now, so before we go on to the second part of the of today's lesson, any questions? All very simple, right? So all you are having a good time. Think is life is good and the class is good, right? Okay, so it's good. Right now, what you I forget which tutor mentioned. So this class, think of it as a bullet train, okay? And then 110 is like a bus or something, a little slower, okay? So right now the bullet train is starting only. I mean, it hasn't really gone. It's accelerating. Now the bullet train is like moving along, going. It's not even cruising yet. It's just moving along, right? But it's important because there are some students who are first time seeing programming, so we give some time to catch up. All right. But just be mindful that, in fact, by next week, by the third lecture, you realize that the train is already on full steam. Okay. Right now we're still cruising. Okay. But slowly we ease you into the whole motion. Any final questions before we continue? Okay, so now is the right time for a short break. Okay, and typically the way it works is this: you have 2 lectures a week, Wednesday lecture and Friday lecture. Right? Wednesday is 2 hours, Friday is 1 hour. Wednesday lecture will be broken into 2 parts. I will tell you something, and then we have a short break, and then we will have resume. Okay, so short breaks typically. What we do is that I will show you some, video clips. During this time, you can either watch the video clip or you can go to the loo or whatever, okay? So today's clip is this clip.
Ladies and gentlemen, at TED we talk a lot about leadership and how to make a movement. So let's watch a movement happen, start to finish, in under 3 minutes and dissect some lessons from it. First, of course you know, a leader needs the guts to stand out and be ridiculed. But what he's doing is so easy to follow. So here's his first follower with a crucial role. He's going to show everyone else how to follow. Now notice that the leader embraces him as an equal. So now it's not about the leader anymore, it's about them, plural. Now there he is calling to his friends. Now if you notice that the first follower is actually an underestimated form of leadership in itself. It takes guts to stand out like that. The first follower is what transforms a lone nut into a leader. And here comes a second follower. Now it's not a lone nut, it's not 2 nuts, 3 is a crowd, and the crowd is news. So a movement must be public. It's important to show not just the leader, but the followers, because you find that new followers emulate the followers, not the leader. Now here come 2 more people, and immediately after, 3 more people. Now we've got momentum. This is the tipping point. Now we've got a movement. So notice that as more people join in, it's less risky. So those that were sitting on the fence before now have no reason not to. They won't stand out. They won't be ridiculed. But they will be part of the in crowd if they hurry. So, over the next minute, you'll see all of those that prefer to stick with the crowd, because eventually they would be ridiculed for not joining in. And that's how you make a movement. But let's recap some lessons from this. So, first, if you are the type, like the shirtless dancing guy, that is standing alone, remember the importance of nurturing your first few followers as equals. So it's clearly about the movement, not you. Okay, but we might have missed the real lesson here. The biggest lesson, if you noticed, did you catch it? Is that leadership is over-glorified. That yes, it was the shirtless guy was first, and he'll get all the credit, but it was really the first follower that transformed the lone nut into a leader. So as we're told that we should all be leaders, that would be really ineffective. If you really care about starting a movement, have the courage to follow and show others how to follow. And when you find a lone nut doing something great, have the guts to be the first one to stand up and join in. And what a perfect place to do that at TED. Thanks.
Okay, this is the structure for today. And you guys can, those of you who need to go to the bathroom can go. We'll be back after this. Yes. Yeah. So and then your friend neighborhood tutor here is going to give you your dog gift if you haven't already collected it. I'll give it already. Only the remaining. Okay. Sorry, who's Ryan? Ryan? Okay. Your technical support is there. After this, you can talk to. Is it? Okay. All right, welcome back. Okay, so now we will continue with the second half of the lecture. Okay. So today typically what happens is this: you will have lectures and you have obviously PowerPoint files. You will also have some source code. RKT stands for record, okay, which is the record file. RKT and STM are the same thing. Alright, so some files we call STM, some files, STM is scheme, RKT is record. It doesn't matter what. Okay, so what happens is this: if you double click on the file, okay, after you install Dr. Record, right, and you double click on the file, you will get this screen. Okay, don't worry about the stuff yet. But this is where the code resides. Okay. Later I'll demo for you the code, some code. But for now, just know that these files are supposed to be run inside Dr. Record. Okay? Alright, so I've told you today about the primitives, means combination, means abstraction. Okay, so now what we'll do is go through an example. Okay, the way that we will demonstrate to you how this thing works is to use what we call an abstract environment, which is this thing called a picture language. Okay, so it's quite a little cute. Okay, so these are three things that I just mentioned in terms of the elements of programming. Okay, so now let's look at this three examples. Okay, in this new thing called the picture language. Now, one thing you can do, okay, is to do this thing called show R cross BB. Okay, if you will run the file that I just showed you earlier, the runes.rkt, and you run it, okay, and then you, later I'll demonstrate to you, but if you do show.r cross BB, you will have this. So essentially what this is, BB stands for building block. Okay, R cross, you see in a while, why is R cross? Show basically shows the building block on the screen. Okay, so R cross BB is a building block. It's a primitive in this language. Okay, it's a picture object. Okay, you can also do this thing called corner BB. If you do show corner BB, you have this thing, which is a corner. Okay, there's this thing called sail BB. It looks like a sail. Okay, so this is what you see. There's this thing called Nova BB, which is this. Okay, there's also this thing called Heart BB, which is kind of cool. Okay, looks like this. All right. And the general idea is this, right? The general idea here is that you can apply procedures and operations onto picture objects. So, for example, when you do show heart BB, show is operation, and heart BB is the object. Okay, this is very simple. Huh? Now, after that, you can of course start to do stuff with it. Okay. So, okay, clear is very simple. Clear means clears the screen. Okay, because there's actually a little window that shows you the stuff you actually draw. If you don't clear it, then there's stuff there. So you clear it, it empties the screen. Then you can do, for example, show quarter turn right sail BB. Now this thing here is sail BB, right? Remember? So when you do quarter turn right sail BB, what you're doing is this. Is what? You're applying an operation onto the picture object. This operation is obviously what? It's defined inside there, yeah. So what this will do is obviously will turn the thing. Okay. This is the operation. You will turn this a picture. And basically picture is this the picture. You apply this operation, you obviously turn it right. Okay. So essentially what happens here is that you have this picture object, you apply operation on the picture object. The whole thing returns a new picture object, which is the original object turned to the right, and then you show it. Okay. This is the result. Okay. And you show it. Now, then obviously you can do things a little bit more, in a slightly more complicated way. What you can do is this. You can define turn upside down, lambda pick, which really is to define what? A procedure on an object. Okay, the pick is actually the formal parameter, right? It's actually the function of x. Okay, so essentially what I'm saying is that I'm going to define this thing called turn upside down on pick. Okay, and what does it do? It does quarter turn right pick, quarter turn right pick. So you take a picture and you're doing what? Turn right, turn right. Obviously that means turn it upside down. Okay. So if you do clear, okay, you clear the screen first, and then you do show turn upside down sail BB, you will have this stuff, right? Because what happens is that effectively you've taken the original sail BB, you've turned it quarter turn right, and then effectively you have it, upside down. Okay, now what I can actually also do is the following. I can actually define the following, which is turn quarter left, right? Picture. And what I do now is that I do quarter turn right, turn upside down. Okay. Turn upside down, I already showed you in the earlier slide, you do it twice. Yeah, one more time, basically you end up turning it 390 degrees, which is effectively the same as turning it to the left, right? Okay, so essentially if you do show quarter turn left sail BB, you have this sail BB, you end up having it this way because it's like turning it to the left. Okay, actually what happened under the hood is that you turn it right 3 times, but the final effect is as good as turning it once to the left. Okay, so this is a very simple example. So what we've shown you is that I have taken some primitives, okay, and I have combined it in some ways to create essentially more complicated objects or operations. Okay, now the other things you can do, okay, the next obvious thing to do is to do stacking. Okay, so suppose you want to do this thing called stack R cross BB, cell BB, okay? What happens is that this is R cross BB, this is cell BB. If you do stack R cross BB, cell BB, what do you think happens? Stacking is stack, right? So essentially this is this. You stack the two, you have this. Okay? You take one guy, you put on top of the other guy, you squish it a little bit. Okay? Because in this world, everything is squished to this square. Okay? So you do stack, you get this. Now, you can stack once, you can stack twice. Alright, so suppose you do stack R cross BB, stack R cross BB, cell BB. What do you think you get? Correct. So you don't get this one third. Essentially, you get something strange like this, right? Okay, why? Because what happened is that you took one guy, you stack on top of the other guy, right? Then you have half, correct? Okay? But when you do the next stacking operation, which is the stack R cross BB over that stack thing, you will take the stack thing and then you squish it to half and you put the thing on top. So in the end, you have this funny looking thing that's not quite so even, right? You stack, but the bottom two things are kind of squished. Okay? And the way to see this is to understand how this operations actually function, in a step-by-step way. Okay? Quite simple, right? Any questions? Okay, later on, okay, with the file run.rkt, you can do this for yourself. Okay, now we do something else. Okay, now, so far you've seen only two things, right? Actually, I've only given you two operations. One operation is called stack. One operation is called what? Quarter turn right. Only two operations. Now what I want to do is the following. I want to do beside. That means I want to take one thing. Okay, just now what I've shown you is I took A, I put it on top of B. Now I want to take A, I want to put it next to B. See what I do? So essentially what I do here is this. I do beside pick 1, pick 2. The two pictures. I want to picture 1 beside picture 2. Then what I do? I actually do quarter turn right, stack, quarter turn left, quarter turn left. Make sense now? Because what happened is this. I've taken two pictures. Okay, two pictures. I need something to stick this here. Two pictures. And what happens is that I turn both of them to the left. Okay? I put them on top of each other. And I do what? I turn it right. Okay? So you can see geometrically what I have done is that I have actually now put one guy next to the other guy using the original operation. Okay? So this is cell, this is R cross BB. The beside will end up looking like this. And the interesting thing to note is that I'm doing this using operators that I had defined before. In fact, only two basic operators, the turn right and the stack. Okay? Now, we can do more stuff obviously. Now, okay, so look at this code. What exactly am I doing here, right? I have this stack, beside, quarter turn right, turn upside down, beside, quarter, whatever. What else is going on? Okay. Okay, all look at this eyeball and tell me what in the world is going to happen. Huh? Okay, so essentially, if this is R cross BB, and you do this stuff to R cross BB, you end up having this thing. Cool little pattern, isn't it? Okay, so it turns out that this set of operations, when applied to this thing, gives you this. Okay, and because of the way it looks, right, I will call this operation make cross. Okay, if it takes the picture, it creates a kind of cross out of the picture. Okay, and let's take a look at the next part. So this is what I just wrote, correct? Okay, what I'm doing here is that I'm taking R cross BB and doing stuff with it, right? Okay. So obviously I can replace it with something else, with a random name. I thought pick. Okay. And I can now go and basically give a name to this thing. Okay. So now this operation is called make cross. So originally what I did was that I wrote some code and I took R cross BB and I moved things around. Now I have kind of replaced R cross BB with pick. I have created a procedure called make cross. Okay. That actually does this operation. Okay. So the idea here is this. Now, we can use this operation. Just now I used R cross BB. Now I can do this. I can define my pick to be what? Make cross cell BB. So this is cell BB. Okay. What I'm doing is that I'm going to apply the make cross operation to cell BB. Okay. And then that object, which is this. So applying make cross to cell BB creates a new picture object. Okay. And what I've done is that I'm naming this picture object my pick. So when I do show my pick, I will see this. Right? Okay. Right. Simple, huh? Okay, simple. Now, then suppose I do the following. I create another thing called my pick2. Okay. And this time, instead of using cell BB as the input parameter, okay, I use this thing called Nova BB, which is this little thing here. And then when I do show my pick2, I will see this thing which looks like a what? Shuriken, right? Quite cool, huh? So this is like a shuriken, okay? Alright, cool. Now, then obviously, we're going to go wild with this thing, right? So you can make cross one time, you can make cross two times, right? Okay, so the point is that I can apply make cross Nova BB once, I get this shuriken thing, right? And then now I can do make cross on that thing. What do you get? Okay, so this is the Nova BB. Make cross one time, you have the shuriken. You make cross on make cross, you have your 4 shurikens. Okay, simple, right? Okay, now sometimes you don't just want to stop at 2, right? Not like Singapore government says stop at 2, stop at 2. So maybe I make more, right? So suppose I make more. How you do this? Now let's take a look. So let's just look at the following code. Now I define this thing called repeat pattern. Okay, you just follow, just walk along with it. Repeat pattern, n is how many times you want to repeat a pattern. Okay, and the two things you need to put, you need to tell the computer, right? What pattern to use, and what picture to repeat pattern on. Okay, so are we clear? So this line, I want to repeat a pattern n times using this pattern on this picture. Okay, so it could be in this case it's like this is the pattern which is make cross and Nova BB is picture. So this thing would be equivalent to repeat pattern to make cross Nova BB, correct? Now what happens? So first of all you do the following. This now let's walk through the code. If n is 0, which means what? You don't apply the pattern at all. Okay, what you do? You will return the picture because essentially I'm telling you that I have this pattern but I don't apply it at all, right? Okay? And I return to you lah, so you have no picture without anything. Now, suppose n is more than 1 lah. Means you must at least apply one time. At least one time. What you do is this, you take the pattern, okay, and you apply it to repeat pattern n-1 pet pick. Make sense or not? No, it doesn't make sense. It's okay. It doesn't make sense, it's normal, okay? Because this doesn't seem make sense, but it makes sense. Okay, so the question is, what does repeat pattern return? Repeat pattern returns a pattern on which, sorry, wrong. Repeat pattern returns a picture on which the pattern has been applied n times, right? So in the same way, repeat pattern n-1 returns a picture, which is the result of the pattern applied on a picture n-1 times. So if you apply the pattern one more time to something that has had the pattern applied n-1 times, you have the result which is something that has the pattern applied n times. That's kind of logic, okay? It's a bit obscure, okay? So essentially pet is actually a procedure. Notice, and then this whole thing is called recursion. Okay, whereby you essentially apply the same procedure, you call the same procedure on itself. Okay? Okay, this is, to some of you it seems very normal and simple, to others it looks obscure. After a while this becomes completely natural to you. Okay, so the idea is this, suppose you do the following, you do show repeat pattern for make cross Nova BB. What do you see? This thing is Nova BB. If you repeat pattern 4 times, make cross on Nova BB, what do you see? How many shurikens? Da. How many? Who says 256? Who says what else? 4. 64. 64. Okay, I feel like that's 7 man. 7 man. So 64. 64. How many? 64. 256. 16. Hey, what's the rest of your house? I must choose something. Okay, the answer is, how many is it? It's 8 by 8, 64. Very good. Okay, how this works out, you're going to figure out yourself. Okay, now, next thing. Suppose I do the following. I do show repeat pattern 3 lambda peak beside peak nova BB. Okay, now just now the pattern I use is called make cross. Right? Now I don't bother. I put in the lambda. Remember what's a lambda? A lambda is the operator that creates a procedure. A procedure is the operator. So what does this do? This one takes a picture and puts it beside itself, right? So I repeat this how many times? 3 times. Okay, suppose I do this 3 times. I apply on Nova BB. What do I see? How many pieces? Who says 8? Let it 7. 8, 6, 16, 4. Yo. Okay, so this is another procedure. The answer is 8. Oh, very good. Alright. Okay. Next, I can do the similar thing. Now instead of doing this beside, I can do this by stacking. What I see? It will be the same thing, but it is vertical, right? Okay. Now, those of you who look at this, who is looking at this thing a bit stunned, not to worry. This is the introduction to recursion. Recursion is not the simplest thing on earth. It is relatively simple after a while because you get used to it in this class. I'm not sure 101 actually covers recursion much at all. Maybe towards the end. Okay, but y'all will be doing recursion in your sleep very soon. Okay, suppose now you do the following. You want to do repeat pattern 4 make cross R cross DB. Okay. You will get this. Okay. Now, suppose you want to have 3 rows. Okay, just now, based on what we gave you just now, the 2 things, the stack and the right turn. There's no way in hell you can get this thing to look right. Okay, so we'll give you another thing. It's called stack frac. Okay, so suppose you do stack frac 1/3 R cross BB, cell BB. Okay, what you will see, okay, what do you think you will see? Guess, I mean, what is it likely to do? It's going to stack R cross BB over cell BB such that the R cross BB takes up what? 1/3 of the height. Okay? It's quite simple, Now if you do the following, if you do stack frac 1/3 R cross BB, stack R cross BB, R cross BB, what do you get? Then you will have this nice little thing whereby everybody, gets an equal share, right? Okay? Because what happens is that when you stack A one over another, you have half, right? And then when you stack the third one on top of the first 2, you give the first 2 2/3 and you take 1/3, then everybody works out. Simple? Okay. So with this in mind, what you can do is the following. Then let's say you want to do the repeat back, you want to do this repeat n times, but this time it's a little different. Okay. You want to stack n objects together. Okay, you want to stack n objects of the same type. Okay, but you don't want them to look weird, right? You want them to kind of be distributed evenly. Makes sense, right? So let's take a look. So again, you want to stack n picks together. Okay, stack n picks. Okay, sorry, stack n pick. Okay, you want to stack n of them. You want to stack n picks on top of each other. So in other words, stack n pick will return you a picture which is the result of the pick repeated n times, all stacked evenly, okay, over each other. Right? First of all, if n is 1, which means you stack 1, which means that you only want 1, what do? You return pick, right? Because, I mean, you're just stacking 1 on top of nothing, so it's just 1, so you return pick. So if n is 1, you return pick. Now, n is not 1, I mean, in other words, it's more than 1. Okay, here we assume that n is at least 1, because otherwise it makes no sense. Alright, so n is at least 1. If n is 1, you return the original picture. If n is more than 1, what do? You do stack frag 1 over n. Okay, this is, because it's a scheme, so it's actually divided 1n, which is 1 over n. You stack frag 1 over n, pick on top of what? Stack n minus 1 pick. Because you know that stack n minus 1 pick, you have assumed that it return you a object which has n minus 1 of them stacked together. So if you take that piece, okay, and you put a new one on top, and the new one only takes up 1 over n of the whole height, then the whole thing, works out nicely. Okay, it's a bit obscure, okay, it requires a bit of visualization and geometry, but pretty much that's it. So suppose you do show stack n3 Nova BB, what do you get? You have this guy, this is Nova BB, yeah? You will have this thing, right? Suppose you do stack n5, you will have 5 of them, neat, nicely stacked together. Okay? Why can't you do repeat pattern? Why can't we just, remember just now I did the same thing, right? I also just did repeat pattern, stack, and got something similar. Why can't I do that? Because if I do that, I can only get all the powers of 2, right? Here, I can get pretty much any integer I want. Okay? So simple, huh? Now, next thing. Okay, so now we do more obscure stuff, okay? Now we do this thing where you do stack n5, quarter turn right, stack n5, quarter turn left, Nova BB. What in the world am I doing here? Okay, you can visualize this, right? So, if you do this, what you will get is this, right? Okay, why am I turning left and turning right? Why? Because I want the thing to look in the same, I want the final result to be in the same orientation as the original one, right? Okay? Okay, so anyway, the point here is that you do this moving around, stacking here and there, and you can basically get this, you can replicate this whole thing n by n times. So, essentially, I will call this n cross n, okay? Okay? Basically, this stack n 5, 5, I extract out 5, it becomes n, and this one becomes n by n. Okay, so now, what does it do? It repeats the same pattern n by n times, becomes some kind of square. Okay, so we do this thing, make cross r cross db, n by n3. What do you get? Okay, this thing on this thing gives you a cross, right? You do this thing on this thing, you have 3 by 3, which gives you 9. Okay? Alright. Okay, this is what it does. Okay, so first of all, you notice in this whole thing you're doing so far, you have no idea how the picture is represented. To be honest, I also have no idea how the picture is represented. So I really don't care, right? So the point here is that you don't know what's going on in terms of how a picture is represented. You have no ideas how things are being moved around. Right, there are only 3 operations that I give you, right? Remember? What are 3 operations? Turn right. Stack. Not show. Okay, show okay lah, but operations on the picture only 3, right? Stack, I think, turn right, stack, and stack frag. Okay? Powerful, right? Okay, so the whole point of this. Oh no, I killed it. Hello? Okay. Okay, so the whole point of this exercise is to show you that using only 3 basic primitive operations, I can do a lot of stuff. Okay, and I can do very complex pictures. Okay, and you do more complex stuff than this in your homework. Okay, and this is the power of procedural abstraction. Okay, essentially you have a primitive object which is a picture. You have no idea how it's being stored or being represented in memory. Okay, you have 3 basic operations. Okay, and with those 3 basic operations, you're able to create all this kinds of stuff. Okay, and you do more stuff. Now, but it's not the end, right? Okay, so it turns out that this thing is cool, it's kind of cool, but we can actually do cooler stuff. Okay, so this thing, okay, this is not a 3D stuff. No, don't put on glasses. This thing is known as the autostereogram. Okay. Auto means that auto is you self. So essentially, if you are cross-eyed, you can probably see this. But actually, in this picture, even if you're cross-eyed, you probably cannot see this. Anybody can see this? You can see this? What is it? My God, you can see this. Okay, I don't know how you do it, but later we'll discuss how you do this. Okay, so anyway, he's right. This thing is a ram head. Oh, very amazing. Oh, this guy is okay. Very interesting. Later I'll tell you more stories. But first of all, this thing is known as the auto stereogram, which means that you should be okay. Later I'll tell you why you can't see this one. But typically, if it's normal one, you should be able to stare at it and cross your eye and you see some picture, some kind of a 3D object. Okay. This one, lady, what's the name, miss? Don't try too hard. What's your name? Eileen, very good. So don't try too hard. I explain to you why. I don't know how you saw it, but later I explain to you why you cannot properly see it. Okay? I don't know how you saw it. Okay, never mind. This is the first guy. Okay, what's the name, sir? Bud. Wow, the musician. This guy is special. Okay? Okay, never mind. So let me explain to you how these things work. Okay, who knows how this thing works? These things work. Who knows this? You know how it works. Okay. Other than you, anybody else? So you bear with me. The rest don't know. So you bear with me. Okay. So, okay, this is physics. This is the high school physics. Alright. So what happens is that you have your eye, okay? You have two eyes, okay? Two eyes. You also have this object, which is something, alright? And typically what you have is this thing called image plane, because fundamentally you are looking at an image, right? And in this case, image plane will be your, if you see this image on the PC, is your monitor. Okay? So you have this image plane, and high school physics tells you that light travels in straight lines, right? You don't know this, right? Okay, so suppose you have a point on this object, okay? Obviously your two eyes, okay, will see light rays coming from the object, right? Okay, and basically the point now is that there are two straight light rays and they hit the object and then they come to your eye, right? Okay, now the left eye, the light ray that goes to the left eye, it turns out, will hit the image plane at point A. Okay, and the light ray from this same point will hit the right eye at another point here. Okay, called B. Okay, it turns out that this point B on this image plane corresponds to the light ray that hits this object at this point. Okay, and this point basically will also have this point corresponding to the right eye over here. Okay, essentially you can see it this way, right? So essentially you can do this thing. Now, what is the, suppose this object exists, what is the obvious thing that must be true? They must have the same color, right? Because otherwise it's a bit screwed up, right? Because then, you know, your brain is all messed up. So obviously, if this is true, they must all be of the same color. Okay, very good. So generally stereograms, the key idea is very simple actually, is to go and compute the set of points that are constrained to be of the same color. Okay, if you're able to do that properly, then you'll be able to fool your brain thinking that the object is 3D. Okay, so the interesting insight is that we can actually compute these things one line at a time. Okay, the question is how do you compute these lines? Okay, now the good news is this, it turns out that we can do this with high school geometry. Okay, so the first thing you do is obviously to create a 3D object, okay, of the 3D model of the object that you want to pop out, right? That's simple enough, right? So typically we use this function xy to represent the depth. Okay, essentially this is a 2D plane, right? The object is behind the wall. So you look at 2x2, the 2x2 xy plane. There's a function fy which tells you how deep the object is behind the plane, behind the wall. Okay. Next, you need to set some parameters. Okay. You need to first decide on how far your eye is from the image, which is the image plane. How far the object is relative to the image plane, and you figure out how far your eyes are apart. Okay. Most mortals' eyes are about 10 cm apart. Okay, who here has it? Okay, so this is normal. Most people have normal size head. Okay, if head is very big, then it's further apart. Okay, now and then you do this computation one line at a time. So how does it work? Well, essentially you take this line, okay, and you do this line, and it must both be red at this point, right, and so forth. Okay. Now and then you keep doing this, okay, and the general idea is this. All right. So essentially, there are four things in this picture. D is how far your eye is from the image plane. Z is how far your image plane is from the object. E is the distance your eyes are apart. Okay? With these three numbers, you can compute S, Y. Yeah, but why can you do this? This is known as what? Similar triangles, right? So essentially, the point here is that you can use similar triangles to come out with this simple relation and compute how far the points are apart. Okay? So essentially, we have done this for you already. Okay? And this tells you something. This tells you why you typically cannot see the thing that I just posted on the wall. Because the thing I posted on the wall, just on the earlier slide, is actually supposed to be displayed on the PC screen. When the thing is blown up so huge, okay, the aspect ratio is completely wrong, which means that typically, unless your eyes are 1 meter apart, you cannot see. So I don't know how Bart can see. I don't know his eyes are like 1 meter apart. This poor girl, Eileen, is trying to squint. I'm like, oh, so poor thing, you don't do that to yourself. Because unless your eyes are about 1 meter apart, you typically cannot see. I don't know how you can see it, okay, but it's good. I mean, maybe you can figure out, teach us later how to do it. Okay, and the strange thing is this. The strange thing here is that most of my students in the current few years cannot see. Most of the students cannot see stereograms. Okay, for some students, they all cannot see. Okay, so no, you can compute, you can decide for yourself, right? But most times in the stereogram generator that we wrote, I think I don't remember. It's probably about 1/2 meter, 50 cm to 40 cm. Your eyes are presumed to be at 10 cm apart, something like that. Okay, so maybe Bart has got slightly different parameters. Okay. So anyway, the idea is this: we have already done it for you. So essentially, all you need to do now is to take a depth map. Okay, essentially a depth map is what? A depth map is actually a model of the object that you want to create. Okay, you take this object, you shove it through a procedure which is a stereogram generator, and out comes a stereogram. Okay. So this is an example of procedural abstraction. Now, I have told you how stereograms are generated, but the truth is that you don't have to care how it's written. Okay. You can do this yourself. I mean, you can just generate stereograms without knowing how it's done. So if you can't see stereograms, that's where your 3D glasses comes in. I don't know whether this works or not. This one, I think the color is not so bright because it's a little bit faint. But actually, you see, in the old days, all we had were autostereograms. But it turns out that we realized after a while that this current generation, all my tutors all cannot see. So in order to basically help you all and not have people become cockeyed after this, we actually then came out with this thing, which is this auto stereograms, which means that you can also, in your homework, generate these stereograms which you can see with your today's Gorgias. Okay. Now this one I don't know. Can you see the 3Dness? Can Okay. The reason you don't see it very well is because the color. The color is not so good. Okay. Hopefully the color that you will see in your homework will be better. It's just the red and the cyan. Okay. Now if you think that this is cool, well, we can do something else. Okay, we can actually do this. Okay, so that means if you cannot see the autostereograms, you don't want to use your glasses to see the stereograms, we can actually do something like this. Okay, what happens is this. This one is what you call, what is it called? Regal stereo or something, whatever. So the idea here is that what we can do to simulate the illusion of 3Dness is to take the image, okay, and basically start changing it in some way which will give you the illusion that is 3D. Okay, what is this thing? That's very good. Very learned. Rest of you don't know, you all need to be educated. Okay. Okay, so what have we learned today? Okay, you've learned that procedural abstraction is to basically define this object that can operate on inputs without knowing how it works. Okay? You have done some recursion. Okay, so recursion is essentially the having procedures call itself. Okay? And the last thing that's not so obvious, okay, is that procedures are actually objects. Okay, now the last thing I will tell you today is okay, so this is just a kind of checkpoint. The key point again today is to learn how to manage complexity using this idea called procedure abstraction. And the reason why it works is because it allows us to hide details so that we can actually focus on the high level problem solving. Okay, so now the key thing is this. The last thing remaining is this. We have written for you the 3D stereogram generator. The question now is, how do you generate stereograms? So the last thing you need to do now is to generate what you call the depth map. Okay, and the way we do this is to use the picture language that you saw just now, and we enhance it. So the idea here is that we use grayscale to represent depth, such that black is nearest to you and white is furthest away. Okay, so you can imagine this thing is actually equivalent to this thing. So it's actually, you think of it as a floating kind of a thing, whereby there's something at the bottom and then the black is right on top. Okay. Now, suppose you have this thing. Okay. Essentially, what this means is that it is nova on top, corner in the middle, and it's floating on top. Okay. So the new command that you have is this thing called overlay. Okay. Suppose you do overlay test VB R cross VB, you will have this. It's actually test VB is on top. Oh, sorry, this is not test. This is sail VB. I made a mistake. Sail VB on top, and then R cross VB at the not bottom, but in the middle between the top and the bottom. Okay. Now you can also do stack overlay frac one quarter. Okay. If you do overlay frac 1/4, corner VB over hard VB, what you get is this, right? So 1/4 means what? 1/4 means that the bottom guy is floating 1/4 ways from the top. Okay, so now with this command, you can actually manage this whole thing. Okay, now then another thing you can do is you can do scaling. Basically, you think your heart is too big. And maybe you have two girlfriends. You got this girlfriend A, girlfriend B. You think the girlfriend B is not so important, you give her a smaller one. So you can then give her the half-size heart. Okay? Alright. Now this is very important. Okay. Now I'm a very practical man. Very practical man. I think that you should learn things that are useful. Okay, this is very practical. Because no, I'm serious. Okay, I'm serious. Because every year there's this day, right? Called 14th of February, right? There is. Okay, it's true, right? And what I used to do, and it's true, and it's a real story, right? It's very simple, and you can do it too. Okay, you go and figure out what first of all you must know what your girlfriend's name is. Okay, figure that out, very simple. Then you create this name, okay? Then you take the heart thing, then you create this stereogram with the name floating over the heart. Very cool. Works all the time. I know it's gonna try it works. Okay, so minimally, if you get nothing out of this class, okay, for the guys, you have a way of learning of cowing the girls. Quite effective one. A bit nerdy, but it's wow, so sweet. You know? The girls, good for you. You now are inoculated, right? Basically, the guy says, do this. I also can. No big deal. You know, so sorry. So the good news is that not many girls in this class, right? So only a few are inoculated. The rest can still work. So the guys have a lot of guys here. So very useful class. I'm serious, sure work one. Mother also works. Okay, I've done a mother also. Mother Day I also did this. So you work on girlfriends, wives. But wife normally is done already because you already have the girlfriend before. So works on the girlfriends, works on the mothers. Sisters I don't have, so I never tried before. Okay, but that's kind of cool, right? So you have this thing whereby you write your name and you put above the heart and it works. Okay? So let me now quickly show you how it works. Okay? Now, so the idea here is that you basically create a depth map, okay? And then you essentially call the stereogram operator on the depth map. Okay, now let's just quickly switch gears to the demo. Alright, so you have this thing called rune.rkt. Okay? If you have installed AutoSkin, right, you double click on this rune.rkt, you have this thing, okay? Right now it looks kind of weird and unfamiliar. After a while you will learn to live, eat and breathe this thing. So for now what you do is this, you go to the top right hand corner, there's this thing that looks like a stick man, it says run. Okay? Let's take a look. Okay. I'm very lazy, so I'll copy. Control C. Okay, so you run. Okay. What run does is that it starts off the thing. Okay. You will basically get this thing called the viewport. Okay. And you will have essentially the interactive window at the bottom. Okay. Now, what you can do, okay, is stuff like show R cross DB. One moment. Okay. Alright, so type this in, you press enter. Okay. Then what happens? Nothing happens. Actually something happens. It's just that you can't see it yet. It's here, right? So everything that I showed you earlier, you can type in here and see some stuff. Okay. You can clear. Obviously, it clears up the screen, right? Okay. Now, then obviously you can do this stereogram, scale, half, cut dB, this thing. Okay. Before this, let me just show you the show. Okay. So when you do show, you will obviously see the HUD lah. Okay. Now then after that, okay, this basically tells you, okay, this thing here, HUD dB is a picture object. Scale half HUD dB is a scaled down HUD picture object. Right. Showing it will show you the object lah, right? Now, instead of showing it, you use the operator called stereogram. Okay? And now you have to press and wait. Okay, because it's not that fast. Okay. So what happens, as you see here in real time, is that Dr. Scheme is computing line by line the stereogram, and I think Buck can see it. Hopefully, I don't know. The rest of you, the rest of you can try, but unless the eyes are about 1 meter apart, typically it's hard to see. Okay, you should be able to see it quite well on your own screen, but this is a little bit big. But what happens now in real time, and this is a bit slow, this shows you that the PC is really quite slow. Your PC should be faster. Okay, but over a while, this thing will start scanning each line and computing. Okay, and from where you're sitting, you should look all random. Okay, except to Buck maybe. The rest of you should see it as completely random dots. Okay. But for those of you, okay, if you do it yourself at home, for a PC that is of normal size, you should be able to see the floating HUD. Okay.
Is there a way to change the parameters for that?
Yes, there is a way to change parameters. Right now, there's no easy user-friendly way to do it. The way to do it is to look at the code and hack it. Okay. So this is how it works. Any questions? Okay. So this is pretty much what we do. Wait, hold on. So let me stop this. Okay. Obviously, there's this thing called anaglyph as well. Okay, let me just try it. Done. So done is okay. So done means that this is done. Okay. Now, obviously, you can also do the 3D thing is called anaglyph. So if you do anaglyph, this thing should work hopefully. Okay. You press this thing. Okay, and it should generate for you the equivalent 3D. Okay, the one that you can see the 3 glasses. I hope this works. There's no point. That should be that. There should still be that. There should still be that of the HUD floating out. Okay, let's take a look whether this works or not. Okay, so obviously you know the picture has nothing on top, right? Because there's nothing on top to begin with. So after a while, the HUD will appear. Okay. And again, the principles are the same. The principles of this 3D anaglyph is the same as the principles of autostereogram. Except what happens here is that we are generating this thing in terms of the two cyan and red. Okay, you should be able to see it with your. Can you see? Can you see it? Huh? Got point now. Jan, right? Not that much. Okay, so maybe you can do better. All right, but the general idea here is that you can also generate this 3D anaglyph. So it's the same command. I mean, the same way of doing it. Instead, put in a different command. Okay, and you should be able to generate either your anaglyphs, your stereograms. You can also generate the thing that moves around. Okay, let's see that works. Okay, so the last thing is this thing called illusion. Okay, it's not very useful lah. Here, I mean, sadly, the heart, even though you move around, it looks kind of like that lah. Okay, so this works best if you actually have an object that actually has more 3Dness. Okay. Okay, so anyway, I leave it to you to play with this. Okay, so pretty much this is the general idea. Okay, and this is the hard thing that you just saw. Okay, so okay, this is pretty much the end of the class today. Okay, before we close, okay, all I want to do is to show you this piece of code. Okay, so okay, one thing you must understand about computer science is we love this thing called foo bar. Okay, something is called foo, something is called foo bar. Something is called bar, whatever. So, there's this thing called foo. Okay, I have no idea what foo means also, so don't ask me. But we call this foo, and essentially it's lambda x star x foo minus x1, okay, and do foo 5. Okay, and based on what you've learned today, the question is, what is the answer? Okay. And the thing is this, okay, now inside IBLE, okay, there is this forum, okay, I would just encourage you to go and participate in the forum. After every lecture, actually before every lecture, I'll post a little thread. You can post on the thread your questions, your answers, whatever, your whatever lah, okay. And if you do that, we will give you some bonus XP. Okay, this class is very interesting. Every single thing that you do that we like, we think is good behavior, you get rewarded in some small way. Okay. So go to IBLE and post something about what you think it is, and we can discuss. Okay. So are there any final questions? Okay. If not, then I pretty much okay. We have come to the end of today's class. It's 11:30. So sorry to make you guys come back on Saturday. But the problem is that if we don't have this class on Saturday, then you'll be behind, and we will get out of trouble. So that after this Saturday is the last Saturday class, hopefully. After this class, you finish on target, and from next week onwards, lectures will be on Wednesday, 10 to 12, as well as Friday, 11 to 12. And next week, I say again, next week, Wednesday afternoon, from 1 to 4, okay, recitations, come to whichever one you feel like it. Okay, you all get me, so highly matters. The best one is probably the second one. The first one, I'm kind of like, I forgot about this, what's happening. Second one, I don't remember. Third time, I'm like tired already. Okay, so the come at 2 o'clock maybe. All right. Any questions? If not, thank you very much. Have a good weekend. Hey, who do I got glasses? Hey, the glasses are in pairs. So you also have hey. Dog gift, you only get one glass, not two glasses. They are all in pairs. You turn the extras to our tutor.